outline of the presentation, and this is introduction to Python. So we'll be looking into the basic aspects of Python as a software. So where we can download that, install them, and integrate a development environment. So we'll look into those aspects. Then I'll give you a quick overview of Python. So if I start what do you call the classification techniques using Python, then some of the concepts will be probably it'll be very difficult for you to grasp. So I'll give you a basic overview, and another thing is that like we won't be doing it in a greater detail. So this is not an introduction to Python class, but then like I'll give you some of the hints and techniques that will be useful for building the classification model and clustering model, right? So then we'll look into the prediction techniques, and we'll look into a lot of other aspects like basic statistics and predictive modeling, and how prediction correlates to an artificial intelligence. So that will be the key point of discussion during the prediction techniques. Then since the want of time, so we'll be restricting it to only two types of techniques. In fact, myself and Sanmusundaram sir has explored a lot of areas in pertaining to the prediction modeling, but since want of time, so we'll be discussing the very important, and you should know the most important technique. It's called classification clustering technique. Then we'll implement that using Python. And initially we plan to have a theoretical session on classification and clustering. Then we look into the implementation, but I don't think it takes the implementation of these techniques in Python takes a lot of time. So we just do the theory and the implementation together. So that's a basic idea of this presentation. Right. So introduction to Python. So not many people will realize that Python is very easy. So even in day one, some of them have asked me, or even one of the presenter has put a query in the chat stating that like, how does that works with the C sharp, something like that. But if you know Python, Python is pretty easy and Python is very clean. So what I mean by clean is that you don't have to really code to a greater level like a C sharp programming or C programming or any other sort of programming. So Python is pretty easy and pretty clean. I'll just tell you what exactly that means. So let's get started. So this is how you download it. So I have given my YouTube channel video, so you can see that whenever you're free. And this is how we can download Python. So you can go to Google and type in Python. The first thing will be python.org. Then you can get into this site, and this will be our basic ideally. The current version up to today, the recording of this session, Python 3.9.0 is the latest version, and this might vary some months ago or even some days ago also. So but it doesn't matter, but this is how you navigate to the Python ID. And Python gets offered for other operating systems also. I predominantly use Windows, and I think some of you also use Windows, but if you're working with Mac and other operating systems, then you can navigate to the corresponding operating system and you can start downloading. Download is fairly the same. You can, it's just like how you install any other software, right? Then a very important thing is the Anaconda distribution for Python. So not many people realize that this is a very interesting and very easy thing that you can make use of um, for creating your Python applications, or even running a code, something like that. So Python is ideally, and Anaconda is the distribution, Python distribution platform. And in fact, it is the most popular distribution platform, and it's open source. One of the advantage of Python and Anaconda distribution is it's all free. It's open source, so you can even share it to people. You can get packages from different contributors and so on. So that's why many data scientists prefer Python over other proprietary softwares. And this even see 20 million user worldwide as of 2020. And this is how we go to Anaconda Python, and you get into the first thing is called individual edition. You can have commercial other versions, but individual edition is more than sufficient. It's the open source distribution, and you can see the video and you can install that. Right. The other IDE is like IDE means like integrated development environment. So which means that the software or the framework or the compiler, you can even say, to be more specific, that is used to compile the codes, Python codes to execute or to get the outcome or the output. I prefer PyCharm. Initially, this was my favorite among the list. Before the Anaconda, the Jupyter Notebook. I'll exactly tell you what that means. This is the standalone package, and the community edition is free. It's a freeware, but the other enterprise editions are paid. And Atom, Spider, and in fact, this answered the query for the one of the participants who have asked, like, can I use C# programming for Python? Yeah, you can go on. You can very well use Visual Studio VS Code. You can go to Visual Studio and you can download this particular thing and you can start using your Python course in it. And Spider is also another thing, but Spider comes with Anaconda itself, so that's very good thing. And Sublime Text is, if you're a hardcore HTML editor, and you probably if you're a web designer, then you probably know the Sublime Text 3 and Vim. Both are like editing text. Those are not very much related to Python, but they are IDEs. You can make use of them to compile Python codes. But PyCharm is approximately the Python's IDE, so that's why I prefer. But some people, some of my friends use Atom, so Atom is also equally good, and Atom is also free. So probably can make use of any of these for your Python programming. And compilers for Python, and the first thing is Jupyter Notebook, so that is what we'll be using throughout this lecture, and that is very easy, and it's open source and it's free, and the documentation of that is pretty good, so you can make use of that for sending your code to your friend or people, or keeping it as a repository. All those things, the Jupyter Notebooks plays a very key role. Then you can, if you are pretty much rely on the online editors, then there's an online compiler called ProgramBiz. So I have hyperlinked here, so you can click that, so that will navigate to the ProgramBiz. Then you can start typing your Python codes in that particular online editor. Then when I install Python distribution, and the first thing I'll be looking is the Jupyter Notebook. You can search it in your Jupyter Notebook. You can do a search in your computer that will take you to Jupyter Notebook. You can click on it, and the installation of that and making use of Jupyter Notebook, I have created a video, and I'll share this lecture notes with you. You can make use of that, because that's all very basic stuff. Probably you can do it when you install Jupyter Notebook, or when you run Python ideally. Right? All right, so this is the Jupyter Notebook. This is the interface, and if you have installed the older version of Python, that will be like Python 2. So I recommend you to uninstall and reinstall the current version of the Anaconda distribution that will have the Python 3. So not much differences, but Python 2 and 3 has got some syntax variation. So probably like Python 3 is a current, so it'll be better um, if you keep up the current version. So that will be better, because if you search for any help online, then Python 3, if you run Python 2, then it will be difficult for you, right? And this is the interface. Then you click on the new Python 3, that will take you to this page. So this is a very interesting and a very good interface, so probably can practice. In fact, most of the people who have learned Python before the Jupyter Notebook felt very intimidated using the ideally. They feel it is not interesting for them at all. Some of my students, before the Jupyter Notebook, they just practice in ideally. They come to me and say, are there any other alternative to it? So we'll suggest R programming or R Studio, something like that. They start working on it. But after the Jupyter Notebook, many people, it creates interest for so many people. So that's how many people started shifting to the Jupyter Notebook. Now, even in YouTube, a lot of lectures on Python, they do it with Jupyter Notebook. So that's kind of a very interesting. And let's get into Python 3, concise overview. So we're not gonna go into a greater detail on the Python 3, but some of the things we're gonna see after the slide gonna be very important to you. So keep that in mind. That will be very useful for you for your programming or for your Python. So these are the 7 areas that I've just listed. Gonna be the most interesting thing for you to understand about Python. not only on Python, about any programming language, but this is more specific to Python. And for example, the Python variables, we cannot have any word as a variable in Python because there are some words called keywords or reserved words. Say for example, you cannot use the word called in, for, then reserve, and so many other what do you call, the reserved terminologies are there. And you can even Google it, so you can find a lot of things. Because what happened is, like, when we perform an inverse function, so I performed an inverse function, and I kept a variable name called in, and it says an error, so it's a reserved word. Like, even and, del, from, not, while, as, I live, in, global, or, with, or assert, else, if, pass, even if PASS is not acceptable as a keyword, because those are reserved words. Yield, break, accept, import, then to my knowledge apprend, class, then continue, then true false is boolean, nobody uses that as a variable. And lambda, because we have got something called lambda expression in Python, so that will be kind of a very thing. Then none, none is also unreserved variable, so something like that. And, all right, so fine. 1 second. All right, so then Python is case sensitive, and for example, uppercase and lowercase matters the most. So in Python, so we'll be looking at that in much detail when we do real programming. Then Python data types, we have got the numbers, we have got the strings, we have got the list, we have got the tuple, we've got the set and the dictionary, and all those things are data types. Probably many people will only know about numbers, strings, list, and tuples might be, and sect and dictionaries are like pretty much way beyond that thing, because those are used for database management, because Python has got a good database management capabilities. You can link with SQL, so that you can create GUI, graphic user interface, using Python as well. The famous thing is tkinter, so you can use that to create the GUI based program. For that you need all these things like set and dictionaries and something like that. Then spacing and indentation matters, because spacing or a white space is matter when indentation. For example, when you do a looping command, then the for loop and the other loops requires the indentation. If you don't provide, then Python cannot recognize that, and that will throw in error. And data frames like packages like pandas, numpy, scikit-learn, all those things or packages. For the data frames is how you manipulate the list or the data sets. So that's what data frame is all about. File handling, how do you make use of an Excel document into Python? You don't have to really type in individual values for criteria, so you can export those things in a form of an Excel file, and Python will read through it. Say famously will use a CSV file for creating that particular what do you call, file handling process. And the next is an error tackling. So error tackling is very important. So we've been practicing Python from 2013, and from that onwards, like we've used different idealities, and we have modified our own codes, something like that, to see which one suits better or something like that. At the initial stage, we felt very difficult, because we'll as a civil engineer with a limited knowledge on programming, we might encounter even a small minor mistakes that will be intimidating. But when you do a lot of programming and you track your errors, and how do you make use of your learning from the errors to how do you make use of a knowledge by rectifying the errors, that will help you to create a lot of other outstanding stuff. So that's what I say. Don't leave error as like error. Don't get intimidated by the error, but try to solve it. Be patient and try to understand the error, and what you call provide solution. Then you'll become a better programmer. It's not only for the Python, but other things. But Python, you might encounter a lot of errors initially. Then prediction in AI, right? So something like I thought I can give you Python introduction in Jupyter Notebook, but I'll reserve that a little later. But let's get into prediction in AI. So that's a core part of our presentation and the session, right? So today we talk about prediction modeling. And in fact, many people ask me like, can you define the decision tree in a layman sense, or how do you tell artificial intelligence its significance even to a novice or a layman, something like that. But one, I don't have to really feel difficult to explain them, because there's a one movie. In fact, I can many would have seen that movie, but they would not have realized the concept, the core concept of it. But that movie is this. Probably you know this movie called Endiran. It gets translated in different regional languages, and the cast is Rajinikanth and Aishwarya Rai and so on. And in fact, if you, I think many of you would have seen this movie, but very few people realize the core concepts of AI gets were discussed in a greater sense and a detailed sense. So that's why I like this movie very much. Not because of the movie, but because of the concept they have, and also the work they have put in to create this movie. So the scientific background of the movie is really very valiant. And this is the scene in which the robot, the Chitti, in fact, in this up to this scene of this movie, this particular Chitti, the robot, was only represented as humanoid. They don't say it's an artificial intelligence until this evaluation. Different scientists evaluate this particular robot for application in army. And one thing is that the first time it gets into this kind of evaluation, the first question they can ask is like the color perception and this shape perception. And the one of the person investigator asked like whether you can put the red cube on the yellow prism, and the robot says it's not possible, the reverse is possible. And after some series of questions, it really baffles and amazes the investigator. But at one point it just fails to understand human emotion, and it gets rejected. And at that point, the so-called villain of the movie, called Professor Bora, he said a very interesting thing called inference engine. He just say it's just a stupid inference engine. So which means that it doesn't have the capability to think, but it has a capability to do the task which gets programmed, or it's just like an inference engine. Some task which is kind of not programmed or not within the what do you call boundary of this, it just fails. Then the hero gets really offended in that scene and is frustrated. And when they go, the next scene is pretty much this thing. There would be a fire in the building, and the hero asks the robot, "Can you rescue people?" And in fact, this is what we call augmented intelligence. In the previous thing, it's just an inference engine, but now it becomes an augmented intelligence, which means that it just say I can withstand 1000 degree Celsius, so I can rescue people. And the hero will be happy again, and he just call the person who rejected this robot, and just say, you see in the television, this robot is really saving a lot of people. And to the surprise of everyone, at the end it rescue a girl in an inappropriate way, and that girl commits suicide. And that's a core value of what we call augmented intelligence, which means that it gets programmed to think, or sometimes it can have a capability to think beyond the command, or in an emergency situation, but not in a greater sense. So then again, the Professor Bora says like your research gets banned, and you have to stop your research or something like that. Then the hero once again tries to incorporate the intelligence capability into the robot, and then he just gives the command like feelings and something like that. And it is what the movie portrays. But actually, what the process is that it makes the robot to train on a non specific way rather than a programmed way. He just without any command, if some entity can think, then that is what we call an artificial intelligence. So it mimics the human behavior. So humans are not programmed to think. So they will be learning from the environment, and they do a response to it, like be it a good or bad, it just like our own perception and thing. So that is how after this is gets banned. And this is a very interesting thing. And the robot does help. It's not a help to the doctor actually. In fact, the robot itself delivers a baby. And in fact, this is a very interesting scene in that movie. And if you note, in that movie, this is where they first talk about the word called artificial intelligence. They say in a press meet, the hero will just say, you see the revolution of artificial intelligence. So it's a very complicated pregnancy delivery, and the robot does that with the intelligent it acquired during the study period, or like something like an association with the heroine. And he gets the knowledge from the textbook. And it, you see, it's autonomous. Nobody is helping the robot to do that, but it does its on own, but it understands human behavior now. So this is how critical in artificial intelligence. So this is pretty much an movie example. But in fact, this is kind of an very realistic also. In some countries, like they use robotic surgeries now. So not like a humanoid like this, but the robot performs with a greater precision. Even cancer cell removal and all those things are very considered to be very complex for human doctors even, or specialists, were done by robots. Like the laser surgeries in the eyes, all done using robots. So all these things are like artificial intelligence. But some people argue that is just an augmented intelligence, where the specialist will always be there, assist the that's only the tool that aids the health. But be it an augmented intelligence or be it an artificial intelligence, both are wonderful. Right. So so far I've talked about the artificial intelligence from the movie. Let's get into let's play with an bot or an robot or something like that. So for that, we say prediction with augmented intelligence. So there is a computer game called Akinator. So I don't know how many of you know that, because that's kind of a bot where you can play. So you can even play that after this presentation. It's called Akinator, and you can Google as Akinator and the first thing. And I have played a game with that, and I'll show you the screenshots of that. And in fact, this is the one. You can even download this from Google Play or Apple Store if you have iOS. Then it is very simple. This is Genie, or you can call Akinator. Ask questions of your character, and it will correctly predict the character. So that's very beauty. It's not only character. For example, in this thing, I wanted to check whether it just predicts Mokshagundam Vishweshwaraya, who is the pioneer Indian civil engineer. And let me try whether the bot finds by asking different question. So it asked me initially, are you looking for a character or object or an animal? It's obviously a character. And I just click character. Then ask me, is your character Indian? Yeah, of course it's Indian. Is your character married? I'm not pretty sure, but I'll just give you as not pretty sure, like don't know, but it still takes that as an input. Is your character an actor? I don't know, but then I just say no. Is your character known for making YouTube videos? Definitely not, because YouTube was not there during this period of time. And is your character old, over 50 years? Yes. And is a character dead? I wanted to confuse the computer, so I just put probably. So I just wanted to use all the options, whether it just finds or not. Does your character likes to dance? I don't know, but I just put no. Was your character a political leader? I just put no, because he's not into politics, but he's in the official rulers period, something like that. So I just put no. Then has your character ever killed anyone? Definitely not. So no. Is your character a female? No. Is your character related to science? I think the genie, the Akinator is just tracing some way to my answer. I just say yes. And does your character have a monkey? But it talks about Aladdin and that character also, but I just say it's no. It's just inappropriate, but then it just no. And is your character Muslim? Then I say no. Then it's your character from the Kirby series? No. And does your character use a bow and arrow? Absolutely no. But it talks about the Ram, Lord Ram or something like that. Then I say no. Have your character been dead for more than 1,000 years? Yeah, definitely no. Then is your character from South India? I think it has found out fairly. It has eliminated all the options. Then I say yes. It's my character Mokshagundam sir is from South India. Yes. Did your character win a Nobel Prize? Actually, no. But I wanted to say probably not, and to use an option. Then did your character die young? No. Then does your character wear something on their head? This is the real point. Like it almost found out. Like there's only two people can be of this thing. One is C.V. Raman, and next will be Mokshagundam Vishweshwar. I just say yes. But if you say no, it will look other questions. Then finally the level of questions will be high. So you don't have to cheat a computer because if you want to know how it gets predicted. Then is your character a physicist? Yes. And then does your character have a British accent? But I'm not pretty sure because those details I don't have. I just say don't know. Is your character from Holland? No. Has your character made a discovery in the law of physics? I think it is fine. It is just correlating to C.V. Raman, sir, but don't know. Has your character been the president of a country? No. Is your character Malayali? No. Is your character a champion? Don't know. Is your character the president or was he? You just see, you see, it does say he because we have given it's not a female. So, and has your character ever lived in America? No. Is your character linked to space engineering? Probably no. Has your character lived in the 20th century? Of course. And is your character linked with water? Yes, this is the real tricky part, like Krishna Rajasagar Dam. Might be it has already found out or just asking me, right? I'll just given you as. Then is your character from Tamil Nadu? It might then looks into Rajaji as well. So no. Then it's a character and architect. So finally I'm done. It finally found out. Yes, he's a pioneer Indian civil engineer and architect. And it just say I think of Vishweshwara. So and finally, yeah, it has found out. So this is as a prediction. This is an augmented intelligence. So it doesn't think my mind, but it just asks me so many questions and it just filters. And in fact, in some of the thing, it looks like a mobile. It's just searching in a mobile phone or something. It might be searching in a Google. It just the process called crawling. It just crawls a lot of websites and see Indian engineer, not female, then South Indian, then we are turban, something like that. All those things, and finally it found me Harish Vishwa. So this is one thing, but I don't want to play this game live because sometimes the Akinator will give me controversial questions also. So that's why I don't play it. This is like augmented intelligence. Then what about artificial intelligence? I'll give you an example. And okay, so in case if you want to try Akinator, you can try this ready mix concrete. I have tried so many times, but it could predict concrete, but not ready mix concrete. You can give it a try, ready mix concrete, and you have to select as an object. So you can do that after this presentation or something like that. Right. Then it's called prediction with artificial intelligence. Something like how many of you heard this famous the Google's quick draw? Quick draw is this thing. So you can go to Google and Google quick draw, and it's a neural network to learn from your drawing or doodling, in fact, to be more precise. Okay, so I'm gonna play that live because this is kind of a very interesting thing, and probably I can navigate to is my screen visible?
Yes, sir.
All right, so we can go to quick draw, and probably I can go to quick draw. I think, yeah, just saying quick draw. It takes some time because it has to load. Yeah, so let's draw. So just ask me draw street light in under 20 seconds. So I just draw a street light. So this is what it just, yeah, it says line
or flamingo,
or flamingo
or castle,
or something
or
like.
sword, or shoe. I see stairs, or
I
paintbrush,
Yeah, I just
or pen,
lost it. Like,
or
yeah,
toothbrush.
it's giving me complicated thing
I
like
see rainbow,
how to draw a
or
squirrel.
boomerang, or garden hose, or palm tree. I see mate, or ambulance, or bear, or shoe, or flyers. I see dragon,
Oh,
or lobster. Sorry, I couldn't guess it.
yeah. So this is pretty easy. So this I'll just draw it very easy. So it's a cannon.
I see line, or toothbrush, or nail. Oh, I know, it's cannon.
Oh, finally I got it. I got it first.
I see diving board, or van. Oh, I know, it's bus.
Yeah. This is a teacher's
I
favorite.
see line, or eraser. I see crayon. Oh, I know, it's marker.
Yeah. So which means Google has found out like three, I think three out of six. Not very bad. Sometimes and all. I'm not. I'm very good. I'm very bad at drawing. So just, I'll go to my presentation. All right. So probably you can give it a try. That was really funny. Has got a lot of things. How our neural network learns to uh, from doodling, right? So basketball is a pretty simple thing. So just draw a basketball. Then something like fireplace. I might lose so many things, but sometimes it. But the beauty of it, like it has got some 50 million drawings, and out of that you can pick any one and can see how people have drawn something like that to portray that as a particular thing. So how that particular machine learns is that it learns from the different exposure, different drawings, something like that. Uh, Probably that it learns by itself. Then it predicts when somebody draws as equivalent to it, so it just predicts, right? So my favorite is giraffe, and you can see there are 1,22,396 people have drawn giraffe. It's doodling, it's not a drawing. When it's very difficult to draw also as beautiful. So just like this, when somebody draws this and this, so there are 1,22,396 database available, and if you draw any one of those, and it will find out as giraffe. Initially I was suspecting like when the initial question comes, that will notify to that bot and the bot finds out, but later on when we make a lot of mistakes, it understands like it's not that thing. It is like it interprets based on your drawing. This is something like squirrel, it just correlates to a dragon, so something like that. So that's very interesting thing. So this is an artificial intelligence. This is, we don't tell that, but we have given this particular, it was exposed to learning to those environment, and it finally predicts that particular outcome. So this is the one that you can make use of it. Like after this you can play this and be free, right? And predictive modeling and analytics with Python. So up to now we talked about some basic things pertaining to artificial intelligence, and we talked about how to install Python and something like that. But now we'll talk about the core idea, what is predictive modeling and analytics. For that, before we get into this, let me show you some of the what's it called. Right. So same. This is the document. So this is the is this slide visible, sir?
Yes, sir. Yes, sir. It is visible,
Yeah.
sir.
Yeah. It's from my lecture notes for the course repair and rehabilitation of structures. And in fact, we have casted 50 cubes. This is way back in 2014, and for M30 grade at VIT Chennai. and it's a 28-day test, and it's the characteristic strength is 30 MPa because M30 grade and 50 cubes, and this is the data. So we have got the compressive strength and something like that. Um, is this compressive strength data gives you some insight? Probably can see this for a couple of seconds, and you can see we have got number of cubes ordered 1 to 50, then we can pretty much see that. But something that is not in order, the right side is the compressive strength for M30 grade. Probably a quick, if you are an expert in concrete technology, probably you have done a lot of experiments in compression, and then you'll find 28.9 is not acceptable because this M30 grade, it doesn't achieve the strength. But talk about strength that is 45.2 for M30, that is something very interesting and way beyond the expected, and something that is probably the same 33.2 and 35, even 35.3 and 31.2. This is almost the targeted value or something like that. And if you add the 1.64 multiplied by the standard deviation, then the 30 will become 38. Then the target strength is this 38 something, 39. It's nearing the target strength and something like that. But we don't do anything else. And finally, we'll just take what we take is average standard deviation. And some people ignore this, but some people take the coefficient of variation. And sample 50, this is a discrete frequency, so we count each and individual stuff and we will name it. But in case you wanted to go analyzing thousands of samples, then we'll go for group frequency, but both are same. But discrete frequency is just like a laborious task, but that's an accurate one. Then it's a mean value is 36.4. So out of everything, the mean value, the average compressive strength derived in that experiment or the 50 cubes is 36.4, which is considered to be an appreciable one. And we also look into the deviation, how the mean gets varied between the reported samples. This is 25 and this is still 50, and square of deviation will take, because in clustering we'll be looking into a type of square which will determine the optimum cluster. But this is the other interesting thing, we take the square of cluster and we'll add that, right? And we find the standard deviation. This is not a population standard deviation, this is a sample standard deviation, so that is why in the denominator is n minus 1, and the standard deviation is 4.4, meaning that each sample get varied by 4.4 Newton per millimeter square. And coefficient of variation, so this is very interesting, not many people realize that this is interesting thing. We'll see how far the mean gets varied with the standard deviation. So how far the samples variability in terms of percentage, so that will become the standard deviation divided by the mean into 100 in terms of percentage. It's approximately 13%. And if it is more than 40%, then 30%, then you should really look into that something is not right in your experiment, so something like that. So not many people look into that. And this is not the end, actually this is certainly not the end. There is another terminology called reliability. Not many people looks into that particular terminology called reliability, because reliability is equally an important terminology, and it's also ignored by a lot of people. And I'll tell you what is reliability. So next will be the group frequency. I'll just group them in class intervals, and I found the midpoint, and I just found out the parameters and the mean, standard deviation, coefficient of variation. You can see there'll be a slight variation in terms of the values for the same sample. The reason is that good frequency is we group based on some particular category, or this is also a classification. So we see we will just portray number of samples having 0.1 to 10 Newton per millimeter square. So there's no sample. Then 30 to 40, then 35 samples, and 40 to 50, the 10 samples. Then we'll take the frequency, the sum of frequency, and we'll do it in the calculation. That's why it's just like optimum. We cannot say this is more accurate, but this okay. But there is a sample size is pretty high. Like for example, 1,000 samples, they cannot really do a individual calculation. Instead, you can take up the frequency and you can start presenting it. Like yesterday's sir's presentation, sir talked about the the regression, multiple regression analysis, like in that individual cells gets put in the what do you call the data analytics tool, and it gives all the R square value and something like that, right? So it's just like a grouped value. And this is very important, it's called reliability. So this reliability is a function of the target, I mean it's not target, it's a characteristic compressive strength minus the mean compressive strength divided by the standard deviation, right? This is a function of, so once you do a computation, you'll have something called phi of minus 1.45454545, something that goes on, and you can even put it into two decimal places, and this is the probability of failure. The probability of failure in Z table is minus 1.45, because minus and plus matters the most here. It is a negative value. So I'm going to find the value of that in the normal distribution table. In the normal distribution table, minus 1.45. So that will be I minus 1.4 and I navigate to 5, 0.05. That will become 0.0735. So this will be the probability of failure. So when you multiply by 100, this is something around 7.35 percentage. So which means that my test is really good. So we have performed really better. So 7% is on the only what you call the variation, something like that. Or it's just like the probability of failure, right? Something, right? Now once we know what is a probability of failure, probability of success we can find, because probability of success is 1 minus probability of failure. So probability of failure plus probability of success equals to 1. So once you know one of the component like probability of failure, we can find 1 minus probability of failure will be the probability of success. So which means that my test, our test is 1 minus 0.0735, which is 0.926, which is 92.6 percentage. So do you really appreciate this, because this is kind of a very high value, because we have performed a 90 percentage, 92 percentage accuracy level. So this is how I just tell my students, like not only the compression test matters, but also the reliability of the test. So that also a very important thing. Sometimes some people brings with the good compression average value, but the reliability can go down also. So sometimes that can happen also, because they might have a huge variation in terms of the standard deviations and something like that. So that's also a very interesting thing that you should. So this is the basic statistics for a concrete or a compression testing or something like that. Now we'll be really looking into oh fine, so this is just a numeric thing, and in fact in the previous lecture people talked about the qualitative analysis also. Qualitative does depends on quantitative, because we need to perform data, but sometimes we will be using some linguistic variables or fuzzy terminologies, but that's a different story. The next will be the visualization characteristics. Say for example, I've talked about the reliability. Then we talked about some 100. This is not is a hypothetical test. So this have 100 cubes done in three sets or something like that, and this is the M30 as well. So we know this is the target compressive strength, which is 30 plus 1.64 multiplied by 5 is a standard deviation, and 38.2 Newton per millimeter square. And this is when you add all the cubes, number of cubes, then that will become 100. So what we do is, in the previous case, we have labeled the cubes, then we have labeled the compressive strength. In this case, we have labeled the compressive strength, and we have found out the frequency of the cubes that falls within this range. Say for example, compressive strength of 1 Newton per millimeter square, they're just 0. No cubes have that compressive strength when you design for M30. Something like 12 newtons as a failure cubes, something like this gets failed to a greater extent. But until this is failed, but after this 21 to something, it's just okay, it's mediocre strength. But something that's way beyond 35, 36 and all, like probably 40, 41, 42, 41, you have got two cubes, because when you design for M30 and if it results in M41 Newton per millimeter square, that's kind of a very fantastic thing. right? Something, but all the cubes add up to 100. This is just a hypothetical what do you call, analogy. And the mean strength matters 28.59. So with the mean strength, we will not able to get anything at all. So average some cubes, for example, in this side, if more number of cubes falls into, then the average will be very high. In this side, if the number of cubes falls into, the average will be pretty low. And in this case, if in the middle row, if the average strength is pretty high, then it's kind of a more optimum. So that is how it's basically means. So but by average itself, we cannot come to a conclusion, because in this case it's predominant that the center low is pretty high. So this is more of an ideal case. We expect 30 newton per millimeter square and we get 28.59. So which means that this red line is a histogram with the polygon and frequency polygon, and which have got the mean compressive strength, and this is the what you call standard deviation, and this is the what you call the target compressive strength 38 or something. This is okay because this is a very ideal case, but not many people will realize that we will or realize or able to achieve this particular thing, because setting at this thing, getting the higher peak at the center coinciding with the mean may not be a easy task. You have to do a lot of supervision, a lot of control mechanisms, and so on. Right. The next is fairly the same, but we have changed the numericals to see what happens. Say, for example, in this case, 47 newton per millimeter square, we have got one concrete that yields that particular strength. Then you see, it doesn't matter from this data. We see, oh, something is 47, then the result is pretty good. And we know something is, the data are very high here, then it's pretty obviously shifting to the right. But when you look into the graph, the histogram, you know that you're not even achieving the mean strength. Your entire peak or the density is towards the left, then this is a very what do you call, we cannot call poor design, but not so good design. So poor design may be something here, but this is not so a good or a complete design, something like that. The next is very important, when which the pattern shifts to the right. So this is our mean. The pattern shifts to the right. So this is a very interesting thing, because uh, you actually need M30 grade or 30 newton per millimeter square, but you actually eventually bring most of them to the right side. In fact, many RMC plant will be focusing on this particular region, because if something goes wrong, they can at least fall in this region. So this is what we call a conservative design. So this is pretty much an interesting thing. A very conservative design or conservative analogy is this thing. So that something goes wrong, we anticipate something goes wrong, so that it can probably push through this particular line and will be always in the same thing, right? But the mechanism or the shape is fairly the same in all the three. Uh, but only in terms of the skewness, it gets varied. The volume and all, it's probably the same, because 100 cube, this is 100 cube, and this is the 100 cube. But the skewness varies, but that is a very interesting thing that you should look into while you do compression strength testing, right? Something like that. And so this is what we basically does in a laboratory, and this has we can call this to be something called inference rather than prediction. And in the couple of slides later on, we'll be focusing primarily on the um, what you call the prediction mechanism, right? So this is an interesting mind map. People call this a mind map. I call the machine learning algorithm. So it has got the decision tree, the Bayesian model, the dimensionality reduction, like the principal component analysis and all, where component analysis and all are pretty much a dimensional reduction. Then instant based is k nearest neighbor, kn, something like that, and clustering, and k means k median, regression, rule based, and regularization, neural network. Probably you have got neural network, some concept of neural network from the previous lecture. We talked about the perception and back propagation networks and ensemble method. In fact, I'm very much interested in teaching the ensemble method, but I don't think we'll have enough time to do the ensemble method. Then is the deep learning, which is the modern revolution. In fact, this is from Brownlee from 2013. You can have a look at this what you call blog where you can learn a lot of things. But this is a 2013 itself. But are the models get shrunk or it gets elongated? The answer is it got elongated to a very greater extent. Now, if you go to Wikipedia and type machine learning algorithms, I think there are so many numbers of them. But one question I want to tell you is, are we going to learn everything or are we going to need everything? So the answer is no. So that is why we always say artificial intelligence is not a single person's job. It is just like a job of everybody or collaborative work. If somebody does work on logistic regression, somebody does reporting, and somebody does what you call visualization of that model. So it's not everybody, one single person does everything. So for a small model we can do in today's class might be okay, but think of something which is way beyond our capability, way beyond our capability. So that's kind of a very arduous task when which the effort is pretty high, and also people what you call get frustrated by individually, and it takes time consuming also. We don't really perform what exactly we cannot um, what you call say. So one cannot perform all the tasks. That's basically the core idea. And that's why I'm saying this all these methods are available, but you should really understand the classifications of this method. Say for example, the classification model, the regression model, all those things are comes under the supervised learning. Supervised learning, what I mean by supervised learning is that, and if what you call if some supervisor helps you to write something, or if somebody as a guide helps you to do something, you really perform better. And you get the knowledge of the supervisor, and you know the circumstances, and if you bound to fail, he just corrects us and something like that. Unsupervised learning is like supposing you're learning a Python which is not in your domain, or you have not studied there for in your BTech or an MTech. So that's pretty new to you. So the reason why we provide this lecture is that it's just like we don't want you to learn like an unsupervised way. We want you to tell you what exactly is that, and what are things that can work, and what are the things that does not work in this particular arena, and what methodology you can use, or what are the visualization techniques you can use. All those things can be dealt in a greater detail in this particular two or three sessions which we have done in this workshop. So that's what basically the idea is all about, right? So these are the different machine learning algorithms. And all right, so quick overview of just pay attention to this table. It'll be it's also an hypothetical table. So as a human, many of you would, as a civil engineer, many of you have experienced reading the reports of compression test. Let's see what you grasp from this. Just pay attention. Just go through this. I hope you have got some idea. Let me tell you, this is serial number hash. I just don't want you to put SNO or something like that. Then this is the water by cement ratio, ranging from what is the minimum value here is I think 0.35 and maximum is 0.60. And the day is the day of the day of testing. In fact, the cube strength 150 by 150 by 150. Per day strength and 28 days strength and 7 days strength. But when you don't see the day, when you talk about 0.5 water by cement ratio for M35 grade, 15.28 is very low, so rejected. So acceptance criteria is rejected, no. But then when you look into the day, oh right, so this is for the day 3, probably this is pretty good, not very bad. So that kind of analogy, then you say yes. And this is the mineral admixtures, the chemical admixtures, this is the workability, and this is the compressive strength. And yes or no, I've added a mineral admixture, then I say 1. If it is no, then 0. And chemical admixture, if I say, if I add, I put 2. If not there, I put false. And workability, I just put medium. And in this case, high, which means because of no, what you call, the super plasticizer, but water by cement ratio is very high, so just a medium workability. And sometimes if it is 0.35, and also they put what you call chemical admixture, then it's medium. Then sometimes is any false here, yeah, 0.45, then it's a false, then it's a low workability, something like that. It's very difficult to work on the particular concrete, right? And then put AC, it's a acceptance criteria, something like that. So this is what basically is. But I've just wanted to use all the data types. So it's, you might think like it's ridiculous, but I wanted to make this is the float point, integer or float. Then this is the integer, and this is the boolean, or people say it's a binary, it's a boolean. And in boolean, in ones and zeros, this is also boolean, true or false, it's a condition. And this is a categorical variable. So remember that medium, low, high. Some people argue that this is a categorical variable, which means it's a variable. It's just a terminology. When I say medium, I understand it's a medium, but Python does not understand it's a medium. Medium means it should be mediocre. High means it should be high. So it's just a category. Python assumes that to be a string. So generally what we do is we will be converting that kind of categorical variables into ordinal variables. Ordinal variables in the sense like for high, we will assume 3. For medium, we will be assume 2. For low, we'll be assume 1. Or low, we'll be assume 0. Medium will be 1 and high will be 2. Something like that. Then this is the integer, and with the float point integers. And this S and no is also a boolean with have two variations, because S and no gets understand by Python. So this will generally take generally considers the boolean. S becomes 1, no becomes 0, something like that. Or sometimes we have to code that to S to be 1 and no to be 0, like in the case of the categorical variables. So which means all the data types I've just added. Two other numerical variables like octodecimal, octal and hexadecimal. Those things, the computer science people, they use for cryptography and other related stuff. So those are other two types of number systems also available in Python. Right. So in the previous case, we talked about the analogy from compression strength testing, and we just say based on the visualization, we in fact does a correlation of stuff. In this case, like water by cement ratio and the compression strength. If high water by cement ratio, the compression strength has to be, say for example, take about only 28 days strength. In 28 days strength, uh, what you call 0.35 is the least water by cement ratio, and you have got high almost higher compressive strength. So lesser the water by cement ratio, more the strength. But workability, when you add a chemical admixture, you'll get to medium. Otherwise, if it is false, this will be low, something like that. So this is all correlation we generally do. But after this lecture, you will not be doing a correlation for every cases. You know why? I have a slide that I can tell you is that correlation does not always imply causation. Say for example, this is an funny or interesting thing. Uh, a person have correlated with the per capita consumption of mozzarella cheese at United States, and he gets correlated with the civil engineering doctorates awarded in United States. But if you ask me in a plain sense, the civil engineering doctorates awarded in USA has got no correlation with mozzarella cheese. But if you talk about the data itself, but if you correlate, the correlation factor is 0.95864. It's almost 0.96. The correlation is very high. So this is a very alarming thing for everybody. Don't go always by correlation. If something gets correlated, this is a funny example. may not be two parameters or likely to be relative, but sometimes some factors may become what we call confounding, which means that that may not be really an interesting factor. Say for example, one basic mistake most of the civil engineering students does is that they add some fibers to some concrete, or they add some mineral admixtures to concrete, and the first thing they will be looking into only the compression strength. Say for example, if they look into some polypropylene fibers, they only comes up with the compression strength. They don't look into the split tensile strength, which is has to be done for the fibers. And those things gets missed. And when they have a correlation with the compressive strength, we don't say that's wrong, but it may not be appropriately correct. So like this, it will become like a mozzarella cheese in civil engineering doctors in the United States. And similarly, you can Google this WordPress thing. It has got a lot of other funny examples also, like the per capita consumption of chocolates and the Nobel laureates. Switzerland ranks one because they have got many number of Nobel laureates, and the chocolate consumption per capita is there is pretty high. The least will be like China, which has got very few chocolate consumption per capita, but some portion of Nobel laureate, something like that. So don't go by the correlation, because correlation does not always imply causation. So this I tell to my students and probably to everybody, because when something is matching, it doesn't mean that it will be true. So this lecture in a predictive analytics will be focusing primarily on those aspects, right? So we'll be looking into that. And the first thing will be a classification model. And before that, probably I can go to my I'll just shift to the Python notebook. Probably, yeah, here it is. I can just share. I'll just this is something like a very interesting thing. So right, so I probably can get help from the existing thing, because since want of time, so I don't go um, creating an work package and starting. Instead, I've got the decision tree, probably this one. Yeah. So what I'm gonna do is I'm gonna go to kernel, and I'm gonna um, restart and clear all output. So restart and clear. Yes. So this is the basic stuff. I think want of time, I'm just not gonna explain individual stuff. For that, before I just can show you something that probably will be helpful for you. This is how you open a new Jupyter notebook, and you can save your name. Say for example, I'll give it a day 3. And the first thing is you can do a mathematical calculation, 2 plus 8, and you have to press shift enter. So when you press shift enter, it calculates it. And you can call this to be z equals to something like 2 plus or 2 x equals to 4. The reason why I'm asking is that why I'm just typing this out is that I've given it a lowercase and x I've given it an uppercase. So if I type in capital Z, it just throws me an error. Name Z is not defined. That's why I told you it's case sensitive. And say for example, another example I generally give it to my student is data and small data. So when I put data, I'll get 2. When I give a small case, I get, sometimes I just say it's a data. So sorry, I have to really compile this. All right. Then if I come back to this, and it just it still gives me data because I've just stored that early. Probably I'll just change it to DATA, or I'll just something like, oh, still gets it, something like that. Right. So sometimes it'll be of case sensitive. Probably I just restart, clear out, because that gets stored in the backend. So 2 plus 8 is 10 data. Yeah, here it is, because it just not recognized that. But sometimes when you give this data is equal to 4, it still saves that data. And when you do retrieval of that, it still gives me 4, because that data I've just not gets erased from that. So something like that is in Python. Right. So one interesting thing I wanted to tell you before we get into other things is the matrix multiplication. Right. So I'll just go to, or you can try it in Google and find matrix multiplication within Python or any other programming languages. You get a minimum of 1 page codes, which tells you the procedure to find the cofactor, and or it's a multiplication. Just find out the procedure for multiplication. If you want to find inverse, it will find the codes for cofactors. Then it finds the determinant of that matrix and just gives you that. But Python, I think this is the one of the interesting thing in Python, which means that there are a lot of packages. Like there's packages called Panda, NumPy, scikit-learn. So many packages are available, so that probably you can make use of that. You don't have to write a complex code. I'll tell you an example. So I'm going to give you import. Just get a NumPy. There's a package called NumPy, used for numerical computation. NumPy as np. Then I just incorporated the packages. Then if I wanted to make some what you call matrix, so we can give np dot array. Probably this is the syntax, np array. Then for matrix I have to open a bracket and a close a bracket. Then for example, let's say 2 by 2 matrix, or we'll take a complex example, 3 by 2 matrix. So this will be one matrix, and I mean one row, this will be another row. So do you understand? So there'll be 3 rows, 3 by 3 matrix, and I'm gonna give something called 1 2 3 for the 4 5 6 and 7 8 9, something like that. So there's a matrix called X, right? So 1 2 3 4 5 6 7 8 9. So something called another matrix, which is np dot array, which is also a 3 by 3 matrix. We just do it reverse, 9 8 7 6 5 4, then 3 2 1. Then I'm gonna give it a enter. So this is 2 matrix. If you wanted to, I think this is the beginner's mistake. What they generally do is they do an arithmetic multiplication x and y, and they'll have something like this. But this is not correct, because what it has done is it has only multiplied the cell wise, 9 into 1 1, 8 into 2 16, and so on. So this is not the correct way. So the correct way is in the sense, like I'll do it the below. I can put an z as a third variable that has got a multiplication of this. It is nothing but np dot product, then multiplied by x comma 1. Then I'll just go to easy to see that. This is the multiplication. You see, it's very easy to multiply two matrix. If you think of some C# coding, that will be very difficult. So matrix multiplication in Python using packages are pretty easy, right? Something like that. And if you want to find inverse, as I told you, this is the general mistake many people will make, because they will just give a function called in. You see, in is green colored. I just can zoom, you can see much better. In is the inbuilt function, so you cannot use that. You can use in, but generally it's not advisable. So inverse to represent inverse, or I can even put it like inverse of a, sorry, inverse of is z or something like that. So I'm gonna find np represents the numpy. Here we have said np as numpy as np, so we'll be representing numpy using this terminology called np. Linear algebra, ALG, this is the short form of that, linear algebra inverse. Then within the bracket, whichever you put, that will become an inverse. Say for example, in this case I wanted to find the z, inverse of z. It will take I have to call that function to see that. Yeah, here it is. As quickly as possible, you don't have to really look into all those things into the consideration, right? Another important thing I wanted to specifically tell you guys is that importing data from an Excel file, something like that, right? Say for example, import, I've got pandas is another data frame package for machine learning, and in fact for reading the data. Then I just put pd, then I just give enter. Yeah, so it just incorporates that. So if I wanted to read some content from an Excel file, so initially I've created an Excel file uh, called CT dataset. Is my Excel file opening, sir?
No, sir, it is still in Jupyter Notebook, sir.
Okay, sir, I'll just share. Is it visible, sir?
It's now visible, sir.
So I've got a sample file, water by cement ratio, the one which you have seen early. We have got something like a recommendation or something like that. So probably this is the file. I've converted that into a CSV file. So just, yeah. So can you see my Jupyter notebook? Yeah.
Yes, sir.
Yeah.
Yes, sir, we can see, sir.
I'm going to home. I'm gonna upload the CSV file. This is the one, CT dataset, and I'm gonna click open. It just asks me CT dataset set CSV. I'm gonna click upload. So it gets uploaded in my Jupyter notebook. Now what I'm gonna do is I'm gonna call a function called data equals to PD, it's a data frame, read underscore CSV, and within bracket you have to give the name of that file. I think the name of the file is CT dataset.csv, right? So now no issues. And when I just see, you see, this is how you call your function. I mean, call your files and other related stuffs into this particular thing, right? So this is fairly simple. You can replace this with a text file or Excel file. I advise you to do a CSV file, because you see the labeling of this is fairly very good if you do a CSV file. CSV is a comma separated value file. So if you save an Excel file, the alignment might change. That will lead to a improper computation, right? And you can even see data.info, which means that we can see what are the file types there. You just say water by cement ratio is a float, and this is a hash. I have got hash also here. This is serial number. And one specific thing I wanted to tell you, data scientist or people who work in Python, is that in Python, the number of rows gets started by 0, 1, 2, 3, and also the number of columns gets started by 0, 1, 2, 3. So this is a nomenclature of Python. This is a general mistake people will make, because that's why I've given a serial number here. You see, the first is not first here; it is a 0. This is a inbuilt line thing gets described in the Python stuff. And this is what it says, like 0 is hash, the serial number, integer, float, integer, object, and m8 considers an object. We can convert that into this is y and n. Y means yes, n means no. This is what we understand, but Python doesn't understand. It just say it's an object. You've given me just an object. Then CA is a boolean, true, false, and AC is also an integer. It just marks as an integer. It just does not marks as a boolean. And a tricky part here is that when whenever you give some text with NA, so this is not NaN actually. If you go to the Jupyter notebook and CT, I'll just navigate to the file. I think it's CT dataset. When I navigate to the file, I've just given only NA, but it automatically converts to NaN. But here, what I mean by is not acceptable. So this is I just purposely wanted to tell you because sometimes you might encounter. So then I'll just change to NAC. Then I'll just give save. Then I close this. In the initial stage, it is NaN. So what I do now is I just do run this code once again. Then NaN will now convert to NAC. Now if I type in data.info, then it what do you call it gets RM gets changed to object. So that's a very interesting thing. Otherwise, what happens is that NaN, which is not a number, it's a missing number. Python considers us as a missing number, and missing number or missing variable computation will be very, very difficult in Python. So that's a separate way in which you can perform that. But as of now, this is if you have a missing data, people generally omit that particular row, or if that row contains some good information, then they add some dummy information, or they mask that particular column for computation. So many factors are there. So that's called there are so many things like missing numbers in random and missing numbers orderly, something like that. So those are very interesting thing, but probably that will be way beyond the session. And this is how it is generally done, right? So very interestingly is there's very interesting procedure to retrieve particular cells. Say for example, in this case, we'll call x equals data dot ilog, and we just have this particular thing, right? So we have got this, we've got semicolon, comma, semicolon, which means that this semicolon represents that I want all the rows. This is the first thing before the comma is a row, and the second thing after the comma is the columns. So which means that if I print x, I make another mistake like same x, you see all rows and all columns have come. So which means that this colon represents 0 to 9 rows. Supposing if I want some specific uh, rows, say for example, if I want to have 3 to 6, then I just put 3 to 6. Then 3 to 6. Then I look into that. I only get the last one. It will just print before the last one, fifth one. So if I put 7, it will print sixth one. So this is one interesting thing that people should know in Python programming, because when they look into the last one, it will take last but one. But you might wonder, 3, I got a 3. It is not so. It is actually the fourth one. If you talk about here, it is 3 is not the third, it's a fourth one, because 0, 1, 2, 3. But if you talk about 1, 2, 3, it's a fourth one. So this it'll be a little confusing, but you can try this data frame so you can understand much better. And if I want to have a column from 2 and 7, and I'll just get something like this. Yeah, 2 and 7, right? And some of you might be asking, no, I want specific rows and specific columns. Then you have to create 2 tables here. Say for example, I want say for example second row and fourth row and fifth column, something like that. So I'll get only fifth column, second and fourth. It's actually third, right? And if I want to have only second row, column number 4 and 5, so I can even say, or I can get 2 and 5, 4 and 5. I get it. This is how we retrieve data. This is a basic Python overview. So far we have not gone into the decision tree, and but you should understand this. This is very important because that's without data frame knowledge and the importing packages, then this may not help us in a great extent, right? Right. And nobody does this because no, nobody really memorize this. They get with the flow when they practice a lot of algorithms and something like that. So for the beginners, this might be great insights. Right. Next, we'll go into the actual decision tree. In fact, I've just eliminated all those things, and you can probably take a look at it. And one advantage of Python is that you can uh, print as PDF, and you can I'll just scroll down. You can download as a Python notebook and LaTeX document and so on. So if you are very familiar with Python in other proprietary softwares, and you can make use of the python.py extension file, as well as you can directly take the text file if you are very familiar with the LaTeX. Right. So first thing for the decision tree. So the type of decision tree we're gonna make is C5.0 decision tree. Say for example, decision tree is a branching algorithm when which the entire decision, say for example, what this success of this presentation or this particular session will depends on so many factors, but people can really think of what happens if this particular Jupyter notebook does not work. What happens if there's a power cut? The presenter saying, what happens if there is what internet fluctuations? The so many factors are there. So which means that I've got all, and power cut is not there, or power is there, and internet facility is there, and the Jupyter notebooks works. And then next is the presentation is success. All these framework, no. So that is what basically we call a decision tree. Like for example, if people play chess, there's an opening, famous opening called Anderson's opening. Generally, it's a different types of opening. They will just say A two to A4 or A2 to A3, something like that. So that movement is just like people who have not practiced that, they'll be really thinking of what the hell is that. So similarly, decision tree is that like it looks into different possibilities. No matter one thing, but what happens, the entire situation gets analyzed. So we talk about only the power cut and some things. Nobody talked about how the presenter is, what happens if we get ill. So that's the other option. And what happens, there's something uh, other things like some other files, what you call uh, some other proprietary software does not work, or something like there's a computer being corrupted, something like that. So if everything satisfy, when we'll have a decision tree, and finally that will be the outcome is the success of the event, same way. So first thing is we have to import the packages, and to import the packages we have got pandas, numpy, matplot library, pyplot. This is the plotting library, and cbon is for visualization, and matplot library inline. This is the magic function. In fact, you can see this is different from the other thing, because there's a magic function when which it sets the backend of MATLAB library to the inline behind, because something that gets done backend will always sometimes required to project in the screen. So that is why we just put the MATLAB library. Then import warnings, because if there's any warnings, it has to be ignored. Errors should not be ignored, but warnings can be ignored, because sometimes we, out of curiosity, we might perform some function that will end up in a warning, but it not be an error, but that can be eliminated. So what I'm going to do is I'm going to compile this. When compiling, it will be this asterisk mark, which means that this will be dark color. So which means that the kernel is busy, it is compiling, which means that at first it is importing the packages. It might take some time, and but it is very quick. So this is number one, which means it got compiled. Next is the import warnings. So I've imported the warnings. Then I'm going to read a PDF, a CSV file called concrete dataset. So I'll show you what is concrete dataset. So I've got some random values. It's not a correct value. Maybe you can really do stuff, and you can experimentally do. So I've got water by cement ratio, slump, and chemical, not chemical, it's a compaction factor, and mineral admixture, chemical admixture, compression strength, and acceptance criteria. Acceptance criteria are target variable. and all these things are interdependent or can be independent also, but that will yield this particular dependent thing or a target variable, right? So it's just it runs through something around 500 lines, something like that. It's 500 because 500 is the number of number of content, and the number one is a header, right? Okay, I'll just close this and just open this thing and just gonna do df is data frame. You can even call data whatever name you can call, so that's not a problem. So I've just got it, and you can see that it just not project everything. You just have 500 rows and 7 columns, and you just project an intermediate rows, it gets compared. Or if you want to have a quick look at the only the main files, like top 5 files, then you can put df head and open. So it will only provide top 5. This 1 2 3 4 5 rows of file, something like that. All right, so you're gonna find df of info. You can see float, int, float. This is all boolean, something like that, right? And our AC is a boolean, so we don't have to convert that into a category. But sometimes if this is not a category, this is something which we talked about early, some high, medium, low, or something like not good, very bad kind of linguistic variable, then you can convert that as a category that will rank that as 1 2 3 or something, or you can even specify that particular thing. So this hash represents the comment. So comment in the sense I don't want it to print that, or I don't want to execute that particular command, so I just put the hash here, right? So two things are there. If you directly run the code or shift enter, it will gets what do you call, it will be just like that without anything, it's just a comment. But when you click markdown, and you click markdown and you can press control enter, it will be like a notebook, like a word document. So this is called markdown. So generally we will be marking down, say for example, I'm gonna say this is a code, something like that. Then I just remove this and I say um, decision tree. Then I just, instead of code, I just run markdown, and it just say it's to enter, it's a decision tree, something like that. So which means that I can write notes, sklearn, scikit-learn I've used here, something like that. You can tell your friends about this, and can share your document. That will be pretty useful. But yeah, so next is the scikit-learn model. So we are importing scikit-learn. It's a scientific package. From that we need model selection and import, train, test, and split. Remember the training data, testing data, and splitting data is not dealt early. Splitting data, since it's being a decision tree, it gets split into 2 or 3 different ways in which you can do that. It automatically splits, we don't have to really do that splitting. And this is very interesting. I've created 2 variables, x and y. X, I'm dropping AC from axis 1. Axis 1 here represents column and 0 represents row. And from this particular thing, I am removing axis. You know why? Because this is our target variable. We will label all other variables as the x variable and remove this particular thing as the target variable. And we will only take this variable as target variable, something like here. Y being only AC, the acceptance criteria, and x being all the thing, all that inclusive of that, right? Something like that. And I'm gonna click enter. Then I'm gonna, this is the syntax for the running the training, testing, and splitting. I've taken a test size to be 0.2, so 20%. Probably in the first lecture we talked about 80-20% or 70-30%. Depending upon that, you can vary this 0.20 to the other side, right? Then I'm gonna click training. Then I'm gonna see what are the things that is taken for training. This is an interesting thing of Python. So Python will tell me I'm taking training, x testing is 0.2, 80% will be training. So 80% of 500 will be 400. 400 of different random, 17, 389, 466. These are the row numbers. All these things gets trained. And x test, I'm gonna take 20%, 100 samples for testing. So other than this database, it will take the testing period. So that's one beauty of this. You can even look into training data sets. Training is the AC column and the different thing. And why train, and this is why test. Then it's very important. So far it's just basic Python. Now what we're gonna do is we can actually apply what we actually need for a particular decision tree. This is called decision tree classifier, and default decision tree classifier is fit xtrain. This is where the function that training and xtraining and y training happens. And we have got the decision tree classifier and scikit-learn metrics import class. This is very important. Classification report, confusion matrix. I tell you true positive, false positive, true negative, and false negative. That kind of a categorization and accuracy score. I wanted to import from the scikit-learn metrics. Then I just put y predict default is equal to y test, and I want to know the classification report. So this is what the classification report. Precision, how false gets clearly differentiated, 36%. How true gets clearly done, 73%. So which means that this is the accuracy is just 65%. Since this is a random model, so accuracy 65 itself is a very big thing. Then confusion matrix, and this will be our true positive, and this will be our false positive. True positive is positive gets correctly classified, and this is true negative. Negative gets correctly projected, and these things are the other features. This is wrongly done. Something like that. I want to do the print accuracy. It's just 65%. Multiply by 100, you'll get 65%. And this is an interesting thing. And so far we have done decision tree. Decision tree already happened. We need to visualize that. So for that visualization, we'll be using this particular code, which is called sklearn tree import tree, a package called graphics. Generally it will not be there in Python, so you have to go to graphics website and download that, and you can make use of that for visualization. I'm just gonna give that. Yeah, it gets correctly projected. And the feature columns is 1 to 6, which means that 1 to 5 the remaining is the prediction. So CS, still CS is there, and it gets projected. And this is the environment. We have taken the graphics help, so we are locating to the thing. If you are working with Macintosh and other Linux, you don't have to do really this particular thing, but for Windows you have to manually say that particular Python Jupyter notebook that I have installed graphics here and the version here, so that you will find out and get me the display of it, right? Something like that. Yeah, so this is the code junk. I'll run through it, and probably takes some time. Yes, here it is, our decision tree. And probably dot data is probably the string IO is the syntax, and export graphis is once you gave the link, it will Jupyter will coordinate with the graphis and get this data. So this is a very big classification, right? I've got something. It is not very visible. You can even save images. You can put it in your desktop, probably desktop, and you can visually see that. Probably I'll just share my desktop. Probably can see my screen, sir.
Yes, sir.
Yeah.
Your desktop is visible, and yes, photo viewer.
Okay, so fine. So this is very clear. So what it says that is anything that is compressive strength greater than lesser than 3.95 will be this category, or greater than will be this category. True will be this, and false will be that. So which means that for my acceptance criteria, compression strength has to be 39.5 and above, and below will be this value, and above will be here. If it is below, there are two definitions. If it is less than 35.5, then what do you call, mineral admixtures has to be nearly zero, which means no additional mineral admixtures. And the water by cement ratio of this is and 0.3, so less than 0.375, and this is how it gets classified. And whenever I teach decision tree to my students, they generally come up and say, sir, it's very interesting and it's very easy. All your code works actually. But the real beauty of that is this is not the final answer. I'll just go to the real beauty of it. This is not the final, this is not the end actually. So you have to really dig in detail. So this model is output, it's not, I'm not denying that, but is that correct? we don't have we don't have any mechanism to say that this is the optimum. So next step is we're going to do an optimization. So what we do is we will there are three factors. One is called maximum depth, another thing is called minimum sample leaf, and the third parameter is not described here. There's another third parameter is called stopping criterion. So that will take a lot of time, so I'm just gonna stop that. I'm not gonna do that here. And the first thing is I'm creating a maximum depth. So once this is there, I'm gonna see I'm gonna perform a cross fold validation or cross validation, and I'm gonna take it from scikit-learn. I perform 5-fold cross validation. N fold is called 5. The parameter I'm going to check is maximum depth. The range is from 1 to 40 levels of depth. Then the criterion. So far we have not defined criterion. So we have just given decision tree as a bracket. We don't have the criterions specified. There are two criterions. There's no criterion specified here. The two criterions, one is called Gini index, which is the more popular, and many machine learning specialists will appreciate that. The another one is a information gain, IG, they call IG. So those two things are used to split the criteria or split the nodes. Say for example, this is a parent node. To split into that, then you should know some Gini value of this, and that gets split again. This is a parent, child becomes parent, then they'll become child, and finally when there's a child and there's no more capability of becoming a parent to branch out, then you will stop. That will be stopping criterion. But we have not given any stopping criterion or any parameters. We just ask the Python to run the decision tree. But in this case, we'll be giving a Gini index, which is a impurity measure or entropy measure, which will classify the impure values and will only provide our range of maximum depth, and it will find out the impurity and just classify that. So I'm going to run through this. And scores, I'm just going to get the scores of the cross validation, and this is the different scores. Actually we can do numerical problems using this. So since want of time, I'm just gonna stop at this. So what we're gonna do is we're gonna plot this particular parameters. Yeah, here it is. It's very ugly. So our training is here, our testing accuracy is only here. So which means that our sample, if you're happy with the beautiful decision tree, then this is the upset. So the training and the testing is not correlating, so or it does not appreciable. Then what we do is we will try looking at the other options. We'll try looking into the minimum leaf. So depth is not a good criterion, so we'll talk about the minimum depth. So minimum leaf split. So what we can have is minimum sample leaves. The same program, I've just take the same n-fold criterion, then minimum samples I've split into half, then I just perform the decision tree parameters, and I found the score, and I just plot that. Yeah, it's fine now. So think of this mean what do you call that maximum depth does not give me any good result, but this is more beautiful, right? So the training and testing is converging here. May not be a very great accuracy. That is because that we have taken a rough data set, so not a correct data set. If you really use this code to perform your experimental value, then probably you can expect 84%, 86%, and your training and testing capability gets met, something like that. And some people ask me, okay, how do I really go and find which one is better, training and testing? So in that case, you don't have to really do. There's one more interesting thing called what do you call parameters optimization. So in that case, we don't really this is minimum split also. So I'll just run through minimum split, minimum sample split. So third criterion, that is really the same thing. And this is also an equally good. So you see, don't worry about this labels, because this is 0.8 accuracy, this is 0.8 accuracy. So minimum split is a wonderful criterion. So when I have got 125 nearing that, then my decision tree is very good. So this is the third stuff. And minimum split is a stopping criterion or the splitting criterion. And supposing if you are very confused, I'm not pretty sure which one to choose, then you can probably find the parameters optimization. I just set the range, starting range, stopping range, and the step by step range. Then I'm gonna give that, and I'm gonna click the run, five-fold cross validation, and the Python will give me what exactly I'm gonna do. So probably I can give fit train, still running. Yeah. So one second, just runs the get results. Yes, got it. The results. Then this is very interesting thing. It will tell me best accuracy. You tell me, computer, what should I do to increase my um, increase my efficiency of my model. So best accuracy the computer gives me is 0.78, 78%. It tells me you give maximum depth at 5, leaf node is 100, and minimum sample split is 50. You can rely on computers like machine learning. So what I do is I again run through it with the help of computers. This is the sample, then as optimized at gave, and 0.785, then I just draw the visual decision tree. Now you may not see a difference here, but if you take a look at it, it has given me a holistic branching, whereas some parameters would be fine tuned to suits the higher accuracy. By seeing this, probably we may not able to see, because both looks very similar, and for that we need to look into the precision. Now the accuracy is 0.79, so what we have got is 0.65. Now we have got something called 0.75, and this is the confusion matrix, and the accuracy is 0.79. So which means this will be our optimum model. So this optimum model is based on the computer suggestion. It's not suggestion, computer run through the sample and they say this is what I can do, the maximum optimum thing that you can get, something like that. So that's basically the decision tree, right? From this you can generate the rules. Say for example, as I told you early, if you have so and so and so and so and so and so, finally you'll get that. So that kind of rules you can get it from this decision tree. So we'll stop with the decision tree because we have got only few minutes left, and we have got a clustering algorithm also, because that is also fairly easy. So I'm gonna go through the clustering algorithm. Probably I've just got clustering. Just one second, I'll just open the I think I've just, yeah, K means. So far we have done only classification, we have classified stuffs, but now we'll look into the clustering, right? So if we start and clear outputs, yes, please go ahead. I'll just quickly run through it because process is fairly the same. So we import data, and we read from the concrete, the same data set I'm going to use. So I'm going to take that, and I'm going to do a scatter plot, scatter plot with the water by cement ratio and compression strength. From this we don't get any understanding, and so what we do is the same thing. ILOC means like it will take a particular all the rows and particular columns, column 0 and column 6, which is water by cement ratio, and 6 probably is compressive strength. So that is why a reason I just explained yours ILOC. So we only separated this two. And this is very important. So this is just a name. You can call any name, data also. K means, this is very important. K and M is capital here, which means this is a function. I'm gonna perform two level K means clustering. The clustering has only two levels, either 1 or 0 or something like that. We represent that by color, two different color, red or blue, something like that. So two colors. So I'm gonna fit the data set X. X is nothing but our this data frame. I'm gonna fit that, and we're gonna find clusters. Since it's a two cluster, this is the 1 to 500. The row 1, row 2, row 3, 500. Row 1 belongs to first cluster. Row 2 belongs to first cluster. Row 3 belongs to 0 cluster. I mean the other cluster or something like that. So similarly, but with this array we don't find anything interesting at all. So what we do is we put that number in the previous table itself. So what we do is in the previous table we add a column called cluster. So one being one particular category, 0 being other category. Here it doesn't mean boolean, it means two different categories, because we have only taken two cluster. K means is two, right? So then we'll try plot that. So let's see how it looks like. Yeah, here it is, red and blue. So the reds are representing 1 or blues are 0. It depends upon the analogy there. But there's only two classifications. Since sorry about that, this is just a random sample, so we don't really have a density at particular place. But in a real sample, you'll have a density, one particular density, and no sparsely located data points, something like that. And the red ones, how does this cluster that? Based on the distance between the associated points, something like that. So twofold classification, I mean the clustering does not yield much result, because they say either here or here. When you draw a line, horizontal line, probably something here. The red one here represents the outliers. Those are outliers. When you remove that, probably your analogy or the interference or the inference from your model will be very high, right? So now I'm performing 4 means cluster. So I don't want to really go 2 means cluster. Now you see 0, there'll be 1 here. Yeah, 1, 2, 3. There are 4 different clusters. Let's visualize that in this pattern. We have got the 4 different types of clusters, different colors that represents different clusters. It looks like a visually good, appealing, but if you really do a data science, individual cluster matters. What is this cluster? This is a pure cluster. This is a mixed cluster, and this also mixed cluster. Something like this is a pure cluster, something like that. If they remove this impurity, then this will become a really a pure what do you call cluster, something like that. This is water by cement ratio, this compressive strength. From this we can understand that when the water by cement ratio is less, the compressive strength is also less. Sorry, water by cement ratio is high, the compressive strength is less. Water by cement ratio is low, compressive strength is high, something like that. So from this we can interpret. And people can ask me, why can't I can perform 7-fold clustering? Yeah, you can really do it. The code remains the same. In that case, we have got the 7 and the data points is the same, and probably this thing, right? Now people ask me, this is 7 colors, you can see the differential clusters. So now it's really good, no? So this cluster, this cluster, and this cluster, and this cluster. People will ask me, how do I determine the number of clusters? So that's a big question. So that's a way in which you can do that, is something called within cluster sum of squares. So you remember in the statistical method, we talked about the sum of the squares that will find out the difference between the mean from the sample, mean value compressive strength to the sample of that particular compressive strength. Same way within cluster sum of squares. So if that is minimum, say for example, if you have got we have got 500 observation. What happens if we have 500 clusters? Individual point itself is a cluster. Then there is no square of deviation. WCSS within cluster sum of square will be 0. I have 500 points. I wanted to put everything as a single cluster. Then the what do you call the sum of square, the within cluster sum of square will be maximum. Way beyond that is no useful. So that brings us to an optimum level of clusters. So I have a 500 database. I need to find out that missing, to find out the X cluster, X number of clusters, so that the distance between, WCSS is minimum. I wanted to perform a minimization function so that I get the lot of clusters, something like that. Lot of cluster, optimum clusters. I just type cluster inertia. Cluster inertia is the same meaning as WCSS, which tells you that a group which has of equal variance, minimizing the criterion, something like that. So that's the clustering integral. Then this is a code chunk. This is what I've talked about early, the indentation. If you don't provide this indentation, Python will throw in error, something like that. So I'm gonna run from before that, just yeah. So I can run 10 samples, because since I've got 500 samples, it takes a lot of time for generating the WCSS. So I've got the WCSS. We need to find where it becomes zero. When it becomes zero, that point it's our optimum cluster. So I know, because I performed this early, it will be around 43. You can perform that. Then you can run this WCSS. Both the things are compiling, and at 43 it becomes 0.00, right? Very good. So which means that what is the number of cluster here? That's very interesting. So because I've given as 43 and I know that's 43 is an optimum for this, so I've given this. Supposing you have 50, then you need to count. This is one cluster, this is two cluster, three cluster, four cluster. It's very time consuming. So what we do is we do a visualization of that. So that's a thing called elbow method. So human elbow has a bend, no, at the bottom. So that will point out the clusters. So which means that I have to plot number of clusters and the WCSS. So which means that I'll just run this. I think it's 43. So I've just changed the previous thing. Yeah. So just 40. From this, you can find that the optimum number of cluster will be something around 2. That's not correct actually. So what you have to do is you have to really zoom that in. It's 43. Sorry, zoom that to a great extent. So this actually bends to a greater extent. So this is not our optimum. Where it touched the x-axis will be optimum. I can still run with 0.1 will be the y limitation. 0.1 will be still goes, and I think I can still zoom a bit with 0.01 accuracy, and it still says something around after 40, something like that. So probably once you know this, it will give you a pretty much good idea. Say in this WCSS, you have to perform that particular 41, 42, and 43 and find out which has got the 0.00. So this, for this particular 500 observation, you can perform 43 clusters, so something like that. So we'll quickly run through K43. So it will take some time because sometimes some cluster will be duplicate. So just is what it says. Then scatter plot. This is the 43 clusters. So if you could see them quickly, you can find out 43 different colors, but sometimes the color variation will be there. So this green is different from this green also, because once you exceed the number of clusters, number of colors in the color database, color palettes, then also you can even see round outline and orange. That's another cluster or something. So this is the optimum cluster based on our model. This is pretty simple. Like probably you can even have this to be one cluster, this to be one cluster, and this will be one cluster, and so on. So all right,